morning. Welcome back to The Claim. I think diamonds might be one of the most overrated gemstones. It's a simple, clear crystal allotrope of the otherwise common element carbon. And despite their apparent scarcity and cost, they're actually not all that rare. Though they're incredibly hard. One good strike with a hammer and they'll shatter into worthless dust. Or heat them. Bring them to 700 degrees, approximately 700 degrees, and they'll literally burn. It'd be an expensive way to heat the tent, but it's possible. I'll concede that they're useful, but almost all the diamonds used industrially are made artificially. And there's the rub. They can be made here on Earth at relatively pedestrian temperatures and pressures. See, try and use that to get out of buying an engagement ring. You'll probably just come across as being cheap. Well played. Just out here on the beach, looking for sign of anything interesting. In and of itself, this isn't all that interesting, but some nice clay. I probably wouldn't have to do much to that to use it directly. Shape it into something and fire it. Decent stuff. Yeah. It's not really worth very much, but might be useful. I was interested in this area originally because of the geology. So we're standing on an accretionary wedge, which is kind of the buildup of material that's left over from when the Juan de Fuca plate, or the ancient Farallon plate, subducted under North America. And so what results is quite a bit of metamorphic rock, or rock that's been subjected to titanic temperatures and pressures from that continental plate collision. And so I was here looking for, I'm here looking for mostly garnet or other things that are created in that metamorphic setting. And so I found a little bit so far, but interestingly today, I keep finding iron pyrite or iron sulfide crystallized. But in addition to that, within this fool's gold, there appears to be actually metallic, deformable flecks of gold in it. So it's not a sign that there's a lot of gold here. I just thought it was interesting, and so I'm going to take that back up to the lab tent and try and refine some of it out and just see what kind of content I've got there. I found this particular sample on the beach, and so that's not really a good indicator that I'm going to find a large quantity of it here. So I'm going to carry on down the beach and see if we can find anything else. Now, gold, on the other hand, has been prized for millennia in its natural elemental form. It's one of the few metallic elements that isn't just another boring shade of gray, and outside of its subjective beauty, it's incredibly useful. It's a good conductor of electricity, it absolutely does not corrode or tarnish, and it's easy to work, and it's rare. The gold that's here is the same gold that was here when the Earth formed, and the only way, to the best of our knowledge, that gold can be created is during the death of a star. If you heat gold until it vaporizes, when it recondenses, it's still gold. We're back up at the lab tent. Now, earlier I was thinking I would just dive right into refining this iron pyrite, but there's a few things about that I'd like to consider a little bit more. Namely, that in the act of doing that, because it's iron sulfide, the acids that I'm going to use to do the refining process are going to liberate that sulfur along with a hydrogen, forming H2S gas. Anybody that's familiar, especially those who work in the oil and gas industry, would recognize H2S as something not to be trifled with. Not that I won't do that. I mean, I'll do it outside. It's just that I'm going to have to configure things a little bit better. But I still need to verify my setup and verify that my, particularly my nitric acid, is still at a sufficient concentration. I'm going to take some scrap gold with a known carat value, in this case 10 carats, and refine it. And for those of you who aren't familiar, 24 karat gold is pure, and all the other carat values are just a percentage of that, effectively, or a percent value of that. And so, in the case of our ring here, 5.95 grams, 10 carats divided by our 24 karat total. In a 10 carat sample, 41.7% approximately is gold. And so we multiply that by our actual weight of our total ring, our 10 karat gold ring, and we have 2.48 grams of pure gold, theoretically, in this sample. Should go without saying that the chemicals I'm going to use are very dangerous, and so you definitely don't want to try them if you're not familiar with it, this kind of thing. And so we're going to start with hydrochloric acid, and then add nitric acid, forming a solution called Aqua Regia. You can't just go out and buy nitric acid. You have to be set up with an appropriate supplier, there's a little bit to that, and probably get put on a list. I'm pretty sure I'm already on a list somewhere. Once everything is in solution, we use another chemical to precipitate it, make the gold crash out of solution, and it'll become a very fine powder. I ran out of light outside today. I had to boil this a very long time. I transferred the solution from that beaker that I mixed it in into this one just so that I could close it up and keep it inside, away from any curious animals. In the interests of keeping the release of these videos to a regular time frame, I'm going to end this video here. Last night, I stopped and I left this sit and settle out, and it cleared right up. It still remains to be a green color, which I think is mostly due to the copper that was alloyed with the ring. Although it is a little yellow. I'm not sure if that comes across very well, but there might be a little bit of gold in here still. So I'm certainly not going to discard this. And even if there isn't any gold in this, it might be interesting to try and use this as an electrolyte for a battery. Not sure if that's possible. Actually, I'll play around with that a little bit. But regardless, I'm going to hold on to that for now. But the remaining sediment that came out is gold and mostly silver and silver oxide here. And so I'm going to try and just pull out the silver alone and leave the gold behind. I'm going to do something a little non-standard. So the next video you'll see this finished off one way or another. We'll be melting it back down into a nugget. But I'd like to save this silver and actually melt them both down. I think I'd like to leave you with a little food for thought. Strictly speaking, gold can be created. I mean, it is created. It's just that it requires cataclysmic temperatures and pressures to do so, and currently the consensus is that the environment required for that is during a supernova. And so, just as a reminder, I mean, that's how all these heavier elements, and the heavier elements that are required for complex life like us to exist are born during the death of these stars. And so, if you can at least temporarily accept the Big Bang Theory as at least a plausible explanation for the origin of the universe, then you really could distill that down to, if you give hydrogen long enough, if you give simple hydrogen gas long enough, eventually, at least through us, it begins to question why it's here.